Hello, Unit 6, Notes 4, exponential decay. I can learn the graph model and apply exponential decay functions. Negative, minus, it's getting smaller. Decay, depreciation, depreciate, there's an R there. Depreciation, right? Decay. Right, those are subtraction ones. So it's the same formula. It's just subtraction. Right? So look at this. Instead of the plus and growth, we have this one for decay. So you just switch to the negative or a minus R. Rate of change, fraction or decimal. So percents, 1, 2. Boom. That's going to be your new decimal. 2 times. T is time still. C value is still your y-intercept. So, 16. Knowing me, I would have did y equals 16. 1 minus 0.45 to the x. And that's how you're going to start all of them. Negative 1, 0, 1, 2, 3. None of that's changed. Alright. I probably usually do 16. If I did that subtraction, it'd be 0.55 to the x. So then you got your handy-dandy calculator. Please, I can't stress enough, if you don't have a calculator, you might need one. So I would probably put 16, parentheses, 0.55. So I literally entered this in my calculator with the parentheses and all. Caret key, negative 1 for the first one. I get 29.1. Then I go 0 for the next one. Alright, I get 16. Yes, I did it right. That needs to be your y-intercept. Well, let's keep going then. 1, 8.8. Then we go 2. If you square it, you're going to get a value of 4.84. I didn't have to round it, that's why I switched to keeping 3 decimals. And then this one, 2.662. So as I look at that, negative 1 is up here at 29. Then I have 0, 16. Looking at that, that's right here. 1, 8.8. 2 is 5. 3 is 2.5. Now look at this. I have this function that decays. It's going to decay close to 0, but not actually get there. Alright? So you got to understand, hey, I'm looking for functions that decrease now. Alright? So I want this going down to 0. Should get to 0, but never touch 0. And when I say never touch 0, it never gets to y equals 0. That's not going to happen. It's just going to get bigger and bigger decimals, like 0.008, for example. Now, number 2. It's got the fraction thing again. Alright? So I probably would have y equals, it starts at 15. I know this is a decay one, so I want 1 minus a third x. Now remember, 1, the best way to write that is 3 over 3. So my math brain works, 15, 3 minus 1 is 2/3 of a pi. So then when I do my calculator, I'm going to answer that as 15, parentheses, 2 divided by 3, caret key, negative 1. So using your calculator is half the battle here. So 15, parentheses, 2 divided by 3, caret key, negative 1. If you can get negative 1 here in 22.5, then go back, get rid of the negative 1, let's go to 0. So go back, and 0 should give me a value of 15. If you don't get a value of 15, you might have typed something into your calculator or forgot a parenthesis or something. Then I change it to 1. When I do that, you're going to get 10. Then when you square it, now we're going to have some nice decimals. 6.6 repeating. What happens if I cube it? Probably the same thing. 4.4 repeating. So awesome. 22.5, that's going to be up here. 0, 15 is right here. 1, 10. 2, 6.6. 3, 4.4. Right? so we're going to go like this, something like this. It'll get close to 0 but never touch it. So that's a nice decaying function. Alright? So, make sure you know how to do decays. The fractions are a little bit tricky. If you wanted to do 0.3 repeating and know 1 minus 0.3 repeating is 0.6 repeating, that's an option too. And then knowing how to put fractions in your calculator with that division sign is a good talent to have. A fully inflated raft loses 6.6% of its air every day. The raft originally contains 4,500 cubic inches of air. Write an equation. So loses, so that's going to be minus, that's decay. So 6.6%, 1, 2. I would argue 6.6% is also 0.66. This line is equal. So when I did my equation, I would write it starts at 4,500. That's what it originally contains, 4,500. Then I would do 1 minus 0.066 x. Sometimes we use t, x, same thing. After 7 days. So then, 1 minus 0.066 to the 7th. Now make sure you know it was after 7 days. This was the equation for every day, so that's why the 7 just becomes that. Usually what I do in my calculator is 1 minus 0.066. You get 0.934. Alright? You need to raise that to the 7th. You get 0.62, and then times it by 4,500. Alright, so that 2 should have about 2,790 cubic inches of air after 7 days. That's a really good answer. That means you understand how to plug in the 7. You understand what you're finding for values, and you can plug that into a calculator and get that. Let's look at 4 a little bit. In the past several years, the population of Campbell County, Kentucky has been decreasing at an average rate of about 0.3% per year. In 2000, the population was blah, blah, blah. Right, decay equation. So decreasing, decay, 0.3 since population since 2000. So population since 2000. In 2000, we started at 88,647. We do 1 minus 0.3%. Get farther away, I need to subtract 0.003 x. Alright, so this is my equation I need to write. So you're going to get 2 points on a quiz for that. Then you go y equals. And then I would do 88647. I might know that that's going to be 0.997. And then the number of years is the population 13 years later. So let's do it. 0.997 to the 13th is going to be a smaller decimal times 88647. Alright, so y equals 85,251.3 people. No, we're not doing decimals. So 85,251 people are in the town in 2013. So really, they lose about 3,400 people in 13 years, which is about 200 people a year, and they're freaking out about it. Well done, Campbell County. Maybe they're running out of soup. Maybe that's the problem. Who knows? Alright? So just be able to answer in efficient reasoning answer. During an economic recession, a charitable organization found that it had, as the donations dropped about 1.1% per year. Before the recession started, its donations were 390,000. Right? The equation represents the change since the beginning of recession, then estimate the amount of debt as 5 years. So our equation, y equals, we started with that 390,000 each year. 1 minus, now I would argue 1.1%, 1, 2, so 0.011, 0.011 t. You can put t or x, I'm not worried about it. This is per year, so it is a time. Now, 5 years later would be 390,000. 1 minus 0.00, I don't really want to do that, so I'm going to leave it. 5 years. When I do this, I finally grab my calculator. 1 minus 0.011. I get 0.989 to the 5th power, so carrot 5 is about 0.946 times 390,000. I have y equal to the contribution since the beginning of the recession being $369,016.74. So I've lost about $31,000. One thing to note there is look at this. They're losing about $31,000, but I rounded to 2 decimal places. Why? Money, we have 2 decimal places. We go by the penny, right? So you can use some skills to know that people are whole people. Money is to 2 decimal places, to the hundredths place, to the penny, right? And know that that's what we're looking for you to be able to round to. So this one says, determine if the following functions are growth or decay. This value, 2/5, that is less than 1, so that's going to be decay. So what I haven't really talked about is this was 0.989. So when I take 0.989 and raise it to the 5th power, it's going to get smaller, so then it's going to be a decay. Right? These are all less than 1. So all of these are going to be decay problems. 2/3 less than 1. 0.55 less than 1. So whenever you have a value less than 1, that's going to be decay. Here is 7x. That's going to be a growth, right? That's going to get really big, really fast. Minusing a 0.5 isn't really going to do much. When we're at 7 squared, we're already at 49. Minusing a half isn't going to do much. This is actually going to be a decreasing one, all right? Even though you're multiplying by 2, that 0.75 is going to get smaller so fast that it is going to be decreasing. 4 to the x, that's going to be increasing, right? 5 to the x. It increases so fast that subtracting 25 does nothing. It just starts lower, and then it's going to build to the exponential function. So the coefficients in the adding and subtraction don't do as much as the actual power of x. So that's how you determine if it's a growth or decay. This will be you when your work is all done. Yes, this was the long packet. You guys all grabbed the packet and were like, this is super long. Yes, because it's graphing. We're going to kind of be done with graphing. All the packets will be smaller, but you have to be able to represent graphs on the ACT, and you need to understand growth and decay as soon as possible. Thanks for listening.